Okay, review number 6. Once again, we are reviewing topics that are required for our UMSL College Algebra credit. And so today we're going to be looking at the different ways to solve a quadratic equation. Once again, this is just about restoring those pathways to where this information is stored in your brain. So here we go, x squared equals 25. What's behind this box? Let's see. Think of a number that when multiplied by itself equals 25. Of course, 5, everyone knows 5 times 5 is 25. But we also know negative 5 times negative 5 is also equal to 25. Hence, that's why when we take the square root of both sides of the equation, we have to remember to put that plus or minus there. Otherwise, we lose an answer, right? So the square root and the square cancel each other out, and we're left with x. And then the square root of 25 is 5, but we've got those plus or minus signs in front of the 5. So there we go. Let's build on that. Let's say we've got something like this. We have to do some rearranging first before we can do the square root method. We're going to go ahead and subtract 99 from both sides. Negative 1 minus 99 is negative 100. We're going to divide both sides by negative 4 to get 25. And then look at that. It's the same problem. We're going to end up with x is equal to plus or minus 5. So 2 answers. All right. So this one's a little bit different because right away this whole side is being squared. So we can go straight to, even though x has company, that 4 is part of the what's being squared, the quantity that's being squared. So we can go straight to the square root thing, and we can say the square root of x plus 4, the quantity x plus 4 being squared, is x plus 4. We have our plus or minus, and then we have square root of 49 is 7. Now, here's the deal. This is how I taught in algebra. It's a real visual way to remember. We're now dealing with two equations. Either x plus 4 is equal to positive 7 or x plus 4 is equal to negative 7. When we subtract 4 from this side, we get x is equal to 3. When we subtract 4 from this side, we get x is equal to negative 11. Those are both our answers. So just take a look at that one and make sure that you're aware that we've got to do, we just have to be aware of that, all right? Don't bring the 4 over. Go first to do the square root of both sides. All right, so this is similar, but I wanted to show you that sometimes when we take the square root of both sides, we don't end up with a perfect square on the right side. So we take the square root of the quantity 2x plus 8 squared, we get 2x plus 8, and then we're going to have plus or minus, square root of 34. I can't even simplify that, right? It's just square root of 34. Now, this is a case where it doesn't make sense to split it up into 2. All right, basically how we're going to do this is this. 2x is equal to, I'm going to subtract the 8, and I'm going to put it first. All right, we could do plus or minus square root of 34 minus 8, but we like to do it in this form. If you weren't taught that, you were taught that in Algebra 2. All right, so we're going to divide by 2. I wonder how to make that thing move. Oh, there we go. Divide both sides by 2. I picked this one specifically. Well, I made this one up specifically because this is what sometimes people do. See, we're fine with canceling 2 over 2, right? That's x. But here's the deal. A lot of times people will just go, oh, yeah, negative 8 divided by 2, that's negative 4. And they'll write negative 4 plus or minus root 34. That's not true, right? You could write it as negative 4 plus or minus root 34 over 2, but most people would just leave it in this form, negative 8 plus or minus root 34 divided by 2. Now, sometimes when you ask yourself, wait a minute, why couldn't I do that? Pick a problem that you already know the answer to. Let's say we had negative 8 plus 4 divided by 2. If I went ahead, now we know the answer, right? Negative 8 plus 4 is negative 4 divided by 2 is negative 2. So we already know the answer is negative 2. But wonder if we did what some people were going to do and just focused on that negative 8 and the 2. We would say, oh, negative 8 divided by 2, that's negative 4. Okay, and then there's a 4. It's like, uh-oh, that's not right. So we cannot do it that way. All right. Look at the next one. All right, now we're going to factor. In this case, we're looking for a GCF, right? Greatest common factor. What goes into both x squared and negative 5x and x, right? So we're going to factor it out. When you factor out something, it's the opposite of distributing. So think about when you distribute. When you distribute, you're multiplying the x by each term, right? But when you factor out, you're actually dividing. You're saying x squared divided by x is x. Another way of saying it is just to leave a line there and go, okay, let's see. X times what is going to get me back to my x squared, all right? So same thing. I could either say, hey, x times what is going to give me negative 5x, and that would be negative 5. Or I could say negative 5x, sorry, I'm going a little crazy with that back. I could say negative 5x divided by x, right? Negative 5x x divided by x. The x's cancel out, I have negative 5. I don't care which way you do it. But something beautiful happens once you do get to this position, because now we have something times something equals 0. And if you think about that, that's beautiful. If I told you I had two numbers hidden in my hand, in my right hand I have a number hidden, and on my left hand I have a number hidden, and the only clue I'm going to give you is that when I multiply these two hidden numbers, they equal 0, you're like, oh, well, I know at least one of them is equal to 0. So we call that the multiplicative property of 0, which basically says when you have two things or more, when two things multiply together equal 0, we know that either x is equal to 0 or x minus 5 is equal to 0. So our two answers are going to be either x equals 0 or, when we add 5 to both sides, x equals 5. And of course, we know that works if we go back and plug in 0. 0 minus 0 does equal 0, and we plug in 5. 25 minus 25 does equal 0. Yay, two answers. Another way to factor is, let's see, did I skip something? Another way to factor, let's GCF this thing. What goes into 2x squared, negative 4x, and negative 16? You're right, a 2. That's the biggest thing we can factor out. Once again, you're factoring out either using that, hey, 2 times what gives me 2x squared, 2 times x squared, or you're using division. I don't care which method you use, but we're going to get that and that. You can always check yourself and say, hey, if I go ahead and distribute, if I distribute the 2 times x squared, I get 2x squared. 2 times the negative 2x, I get the negative 4x. 2 times negative 8, I get that negative 16. Let's see if I can do that right. All right, now you're like, oh, this is great, Miss Overby. We have the something times something equals 0. And you're right. We could go that route. You know, why not? Let's go that route and say we have a 2 times this equals 0. Either 2 equals 0, which we're like, no, not true. Okay, we drop that. Or x squared minus 2x minus 8 equals 0. But then we're in that position of, oh, we don't have something times something equals 0 anymore. What can we do? And then we remember that when we're given a quadratic trinomial, we can factor, sometimes when they cooperate, factor by making two binomials that multiply together to equal the trinomial. And how do we do that? Remember, we put the x and the x here, and then we say what two numbers multiply to equal negative 8 and also add to equal negative 2? Well, I know that negative 4 and 2, right? Negative 4, now it doesn't matter which one you put first. Negative 4 times 2 is equal to negative 8, and negative 4 plus 2 is equal to negative 2. This should be coming right back to you because we did a lot of it in Algebra 1 and Algebra 2. If not, email me and I'll send you some longer videos that I made for my Algebra 1 kids. All right, here we go. Now we have that beautiful multiplicative property of 0, which we say either x minus 4 is equal to 0 or x plus 2 is equal to 0. And we've got our two answers, x equals 4, x equals negative 2. If I had more time, I would stop and show you how if we plug those numbers in, they will work to make the left side equal to 0. All right, so now we've got x squared minus 25. There's no GCF. We can't do that. There's no, it's not a trinomial. We can't factor it into two binomials, but we have two options. We could either go, wait a minute, I know what this is. I'm just going to swing that 25 over to the other side and solve using the square root method. You can do it that way. So that's method number 1. Or you can use method number 2 that says, oh, I know what this is called. This is called the difference of two squares. And I know the difference of two squares can be written as x plus 5 and x minus 5, right? Because if we were to use it to one too many videos in a row for me to make. If we distributed, we get what? X squared plus, or x squared minus 5x plus 5x minus 25. The 5x and the negative 5x cancel out. Voila. We have our multiplicative property of 0, and we get the same answer, don't we? I don't care which method you use, though it is important to know how to factor the difference of two squares. All right, we can't factor this, can we? I can't think of two numbers that when multiplied give me -4 and when added together give me 2. And so unfortunately, or fortunately, we're fortunate to have it, we're going to use quadratic formula. So basically those a, b's, and c's reference the coefficients in front of each one of our terms. A is a coefficient in front of x squared, b is a coefficient in front of the x, and c is the constant term that has no variables, that's -4. And we're just going to plug it in. And once again, I am going to sing for you. Those of you who had me for Algebra 1 know what a beautiful singing voice I have. All right, haha. X equals -b plus or minus square root b squared minus 4ac all over 2a. Give it a try. You will remember this all the way up till you're 99, maybe even 100. We'll see. All right, so here we go. X equals, so in this case, b is 2, so we're going to plug in -2 plus or minus, the square root. We've got b squared is 4 minus 4ac, so what's a? 1, and c is -4. Oops, didn't need that all over, did I? Okay, all over, c is -4, all over 2a, and a is 1. I'm going to take us a little bit, as far as I can without a calculator. We've got 4, and then we've got, remember, we've got to do multiplication for PEMDAS, right? Before we subtract, we have to do this part, -4 times 1 times -4 is 16. So 4 plus 16 is square root of 20. And once again, you just pick up your calculator, right? We could stop here, or we could go a little bit further. I could break it down and say -2 plus or minus. I could break down 20 into, what, 2 root 5. That doesn't make sense. You could stop here. I'd probably still give you credit. And then we can actually divide both terms by 2, right? -1 plus or minus square root of 5. And this is a much better answer than just giving me a decimal approximation, by the way. Is it okay if you just get here? Yes, that's okay. Unless when we're using delta math, it's not okay. So if it's not, we will address that in either the classroom or in our Zoom time together. All right, and completing the square, and this is our last method, right? Because we can solve quadratics a couple different ways, right? We can do the square root method, we can factor, we can take out the GCF, we can complete the square, and here we go, let's complete the square. All right, just note that if we brought the 5 over, it is not a perfect, or it's not a factorable trinomial, and so completing the square refers to we're going to create a perfect square trinomial on the left side, and we do that by making a space for a quantity on the left side. And how we pick that quantity is we take our middle coefficient, the coefficient in front of the x, we take it, we divide it by 2 to give us 4, and then we square it. 4 squared is 16. And that is what we plug into our little line there. We've created a perfect square trinomial. Now, what do I mean by perfect square trinomial? Well, let me answer that after I remember to add that 16 to the other side. All right, so whatever we drop into the left side, we better drop into the right side. Otherwise, we've compromised our equation, haven't we? It's no longer going to be true. So we've created on the left side a perfect square trinomial because, look, when we factor it, what two numbers multiply to equal 16 and add to equal 8? Well, 4, right? And let's go ahead and fix this side. 5 plus 16 is 21, right? All right, so when we see that, it's like, okay, that's great, Ms. Overby, we have something times something equals 21. Well, we need a 0 over there. Well, we don't really, actually, because we can rewrite x plus 4 times x plus 4 as the quantity x plus 4 squared. And as soon as we do that, voila, we're back to the square root method, which is beautiful. We're going to go ahead and solve this. We're going to take the square root of both sides, putting that plus or minus in front of our number, and square root of x plus 4 quantity squared is x plus 4 plus or minus root 21. Since we cannot make root 21 into an integer, we're just going to go ahead. We're not going to split into 2 like we had before. We're going to bring that -4 over, plus or minus root 21, and this is the answer. Once again, I made a really great, I mean, of course, it was great. I'm going to believe it's great because I made it, but a video at least for my Algebra 1 students over completing the square. Once again, just send me an email, give me a heads up at some point if you need that longer video. All right, that was a lot. Thanks for joining me. Hopefully your pathways got reminded of all this beautiful information stored in your brain. I will see you later. Bye.